Welcome to the channel Data Science Demonstrated. Today we have a very interesting topic about sustainability, electrical vehicles, and we are going to link all that to data science. And today I have a very good friend of mine, Ramani, who is in the studio. Welcome, Ramani, to the show.
Thank you, Pranay. Glad to be here. And for all of you out there, this is my first YouTube ever. So nervous and excited at the same time.
No worries, yeah. So Ramani has got a lot of experience in the energy sector. So Ramani, can you tell the audience about your experience about energy and sustainability?
Sure. So I have about 17 years of experience working in the energy sector in different parts of the world. And I've always focused on energy from a supply perspective. How do you build power generation plants of all technologies, supplying countries, communities, regions? And that work has slowly led me to trying to figure out electrification of everything, of industry, of mobility. And that has naturally led to electric vehicles. And I'm deeply interested in that subject and working in it now.
First question I have is, we all talk about sustainability. And I think everybody's interpretation of sustainability can be different. But can you explain to me what is sustainability in a very simple terms?
Sure. There is a lot of jargon around sustainability, that's for sure. In my mind, sustainability or sustainable living or working is simply a practice or a way of doing things that can be done day after day, year after year, without any significant impact to one's health, one's well-being, and importantly to one's wallet as well.
Yeah.
So anything that you keep repeating as a practice is to me sustainable. For example, we go to somebody for advice and they say if you have to lose weight, you have to run a marathon one every week for the next 8 weeks. That's not sustainable.
Yeah.
But if another person tells you to lose weight, you simply have to go for a half an hour walk every day. That's something we can do throughout our lives, no matter how old we are. And that makes it immediately sustainable.
Okay. No, this is a fantastic definition, and frankly speaking, it is jargon free and I kind of understand it. So if I understand it correctly, sustainable is something which you are doing, which is good for you, which is good for the planet, but more importantly, it is, you can do that daily on a daily basis. It is something which is going to be sustainable in a long run.
Absolutely. I think long run is the key thing.
Right, perfect. Thanks for that explanation. And so when we think of sustainability, we cannot detach it with the subject of electric vehicles. Right. So can you tell me on how this subject of sustainability links to EVs or electrical vehicles?
Right. I think in this modern world, we can all agree that we spend a lot of time in moving ourselves from one place to another. Whether it's for work, for leisure, for meeting family, whatever it is, transportation is a big part of our lives. And it needs us to think deeply about how we can keep doing it without, for example, increasing pollution in our cities, without spending too much money on things, without being attacked by noise pollution and all of that. Right? And naturally, an option which is open for us today is electric vehicles, which was probably not existing 10 or 15 years ago. And therefore, it demands our attention as to whether it really is a right choice for sustainability or not. And this is can become emotional.
Okay.
And what I'd love to discuss today is how can we look at it quantitatively through the lens of data and try to ground our thinking about sustainability with hard data.
Excellent remark, Ramani. So, since there are lots and lots of electrical vehicles, there is also lots and lots of data out there. What we call it as this open data. Even a lot of manufacturers also promote their own data out there. So Ramani, talking about data, as a data scientist, I could not resist going out there on internet and try to collect all different data which is available on EVs.
Okay.
And to my surprise, I found that there are many models, EV models out there. I was first thinking that it is only Tesla.
Right.
But now there are lots and lots of EV models out there, and I found there are almost about 650 plus models which are currently being manufactured. So this was kind of quite eye-opening. And can you tell me on why so many companies are making this EV, and what is kind of motivating them to produce more and more of EV models?
Right. No, I didn't know there were 650 models, Pranay. Quite interesting. I think though, if you think back, it's quite natural because electrification is new, electric vehicles are new. So you have a lot of fresh blood, a lot of fresh minds wanting to make the next best electric vehicles, and Tesla is the most famous. But there are a lot of these young industries wanting to make different car models. It's also a fact that the making of a car has evolved, right? So instead of making a hard model, you can now make a digital model, you can have software. So many others. So the universe of companies that are trying to create the models are large.
Got it.
I think that's what's behind it.
Got it. No, so great. I think that's a great insight, and this also kind of ties this insight into this data.
Absolutely.
And I think this is very critical when you are in the data science world. It's good to look at the data, but it's also very important to interpret why this results. And I think this insights from an expert, a person who has got experience, is also going to help you to better understand the data.
I'm going to take some of the pressure off me and put on you. So now that you say we have 650 models, can you help us understand what are those 650 models look like? Can you help us somehow categorize or cluster the data in any way?
Yes, definitely. Yes, Ramani, I think that is a very interesting question. So what we can do is, when you have lots and lots of cars, and each of these models also have lots and lots of characteristics, we can apply a technique called as clustering, which will help us to group all these cars into smaller number of groups so that we can understand from a holistic point of view what are these different clusters of cars which are existing. And let me show you with this particular example. So here I have on the screen, you see I have all these different cars, and all these cars have got all these different characteristics such as acceleration per second, the top speed, range per kilometer, efficiency, all these different characteristics are there. And what you can do is you can now cluster all these cars into 3 clusters. I've chosen 3 clusters just from interpretation point of view. So we have the green cluster, we have the orange cluster, and we have the blue cluster. And when you hover over these clusters, you'll be able to see on what the types of models are there. So as per my interpretation, I found that you can cluster all these cars into clusters based on the body style. You have first cluster, which is this body style SUV, like larger cars. You also have the body style which is hatchback, and then you also have this body style which is station or sedan. So overall, you can see that on one hand you have this larger EVs like SUVs and pickup trucks, and on the other hand you have smaller ones like sedan, and then you have hatchback which is in between.
Okay, great. And that's useful because I think the size of the car is the first thing we would all look at when selecting a car, because that's what determines the function for which you need a car.
Yeah, perfect. And while I was doing this interpretation, I came across an important field which was this efficiency. Efficiency watt over kilometer, and I would like to have your insights into what is this. So Ramani, here you see an histogram which has got this parameter efficiency watt over kilometer, and it has got all these different brands organized based on this particular parameter. So can you tell me what is this particular efficiency watt over per kilometer?
Sure. So if we look at the bulb behind us, right, it's probably something like a 60 watt bulb. And if it burns for 1 hour, that means it consumes an energy of 60 watt hours.
Got it.
So when we look at watt hour per kilometer of a car, basically it tells you how much energy the car consumes to cover 1 kilometer. So if it's 100 watt hours, just as an example, that means the car takes 100 watt hours to cover a kilometer. That in itself might not be so useful to our viewers, but then if we look at our electricity bill, if we charge our cars at home, then we can look at how much our electricity supplier is charging per watt hour, and then you can directly figure out how much your car costs you to travel 1 kilometer. So that's how you take the efficiency, and then you immediately try and understand how much it costs you to drive per kilometer. And that's a great, what you have there is actually a great way then to compare an electric car to a petrol or a diesel car, because those cars then will tell you how many liters they need for you to travel 1 kilometer or more correctly 100 kilometers, because that's then you can, that's what they describe. And that's a great way for all of you to figure out how much does my petrol car cost me to run, and how much does an electric car cost me to run.
Very interesting. So can we say that this is a parameter which kind of reflects sustainability?
Yes, absolutely. Because like I have always maintained, economic sustainability is the most important. If something is good for us but it costs too much, we'll give that up very quickly, or we won't make that decision, right? So this watt hour per kilometer is the best measure to tell how much a car will cost us to run.
Got it.
And that is sustainable.
Got it. Okay. Excellent. So I think this is a very good interpretation of data, and I think this also shows the power of data analytics and how you can tie it up to your day-to-day questions, and how you can tie it up to your day-to-day activities around sustainability.
Absolutely. Nothing like seeing a number or a graph to tell you, yes, my heart was probably making the right decision, or no, man, I was wrong and I need to change my decision.
Exactly. Perfect.
Pranay, I have to ask you one thing.
Okay.
Today we live in a highly politicized world. Yes, Tesla seems to be the electric vehicle that most people think of when they think EVs. But obviously, you just pointed out, right? There are 650 models. If I'm living in Europe, which I am, and I want a car that I say, I like the Tesla, I like its design, the way it looks, feels, etc. But I want something made in Europe. Can your data help us find such a car?
Yes, so definitely I think this is a very relevant question, and we are all also driven by the political things which are happening around the world, and data science can help you to make the decision based on your political thinking also. So let me show you this with a live demo. So here you see something called a similarity search. So similarity search is going to help you find which are the closest car to any given car. Now, as you have seen this, you have lots and lots of data in the field.
Okay.
Like this car data has got almost about 30 plus fields. Right. So manually looking at all the different fields and try to find out which is the closest car may be a bit tedious. So these algorithms can help us, and they can automatically give you which is the closest car to any given car. And here we are going to find out what is the closest car to a Tesla. Okay. Right? But which could be probably a European car. But let's see what the data and algorithms have to say.
Sure. Before you jump into that though, the way you've outlined it, it almost seems like a Netflix recommendation.
Yeah.
Is that similar, Pranay?
Yeah. I think you kind of rightly mentioned this. So Netflix recommendation, film recommendation is based on recommending you movies which are similar to your interest and taste. So this is exactly similar, but we are going to apply, you can say that recommendation algorithms, so similarity algorithms now to EV car data.
Perfect.
Right.
Lead us on.
So here I have different characteristics based on which I want to do this comparison. And here there are different algorithms to make these comparisons. You have Euclidean distance and cosine similarity, but for the moment let's stay with this Euclidean distance measured. And here you see all these different cars, right? And the different cars has got all these different fields over here. And what we are interested to find out is what is the closest car to this Tesla Model 3. So I can give this record number enter here, which is the Tesla, and try to get the similar records. And here I get all the list of models which are very similar to Tesla Model 3.
Okay.
And voila, I find a European car, BMW i4, which is very similar to Tesla Model 3, but it is European made. Okay. So if I am driven by political decision, I now have a choice that I can go for BMW, I cannot go for Tesla, but let us also see on why these two cars are very similar, right? Okay. So here I have some visualization which is in form of an radar chart, and you can see that I'll just try to keep the BMW car, and I will just keep the Tesla Model 3, you can see that both these cars have got almost about very equal number of fast charge kilometers. It has got an almost equal amount of range per kilometer. So there are many characteristics which are kind of matching it. For this reason, both these cars have been found to be very similar to each other.
Okay, interesting. So these attributes are all interesting, Pranay. But what about that big elephant in the room? The price of the car.
Price of the car.
Can you show us how that compares between the two cars we've talked about?
Yes. So here I have the Tesla and here I have BMW.
Okay.
Right? And let us see the price of both. So the BMW is in fact a bit expensive, which is at 65,000 euro compared to the Tesla Model 3, which is at 55,000 euros.
Okay. So clearly we then have a choice between a car that might satisfy our political heart but which is more expensive than the choice which seems to a default choice of an electric vehicle.
Yeah.
Can you help us then figure out maybe some other parameters that will help us decide what's more sustainable in the long run? Because this is just the upfront price of the car.
Agree, yeah.
Can you get us into that detail of the cars?
Sure. All right, Ramani, that is a very interesting question. And here I would like to take the help of machine learning to find out that what are some other factors which are helping to understand the price of the car.
Okay.
And if we find some factors which are sustainable, it can help us to overcome this political decision.
Absolutely.
So on the screen you see machine learning model which will help us to understand what is the link between all these factors and the price. So here I've taken all the different characteristics and I've taken the target as price category. To simplify it, I've just divided all the data into two categories. 0 is all the cars which are less than 60,000 and 1 is all the cars which are higher than 60,000, because 60,000 I found was an average price of the car. So here, for example, you can see that cars which have an low acceleration per second, it means that they reach 100 kilometers in a very small amount of time.
Right.
They are highly priced cars.
Makes sense.
You also have things like efficiency, watt hour per kilometer, which we have already seen.
Right.
So you can see that cars which are efficient are in fact highly priced also.
Makes sense.
Now let us try to see on how this links to our BMW car. This what you are seeing is a kind of an overall analysis.
Indeed.
So for this we can go into something called as machine learning model training, which you will see over here, where you can try to create a model which is linking all these different characteristics to the target characteristic.
Right.
And I am able to predict the price category of the car with almost about 88% accuracy.
Okay,
right?
Interesting.
So I can now use this model specifically on my BMW car, right?
Okay.
So let us see that for this particular BMW car, which was BMW iX3, all these different parameters,
Right.
we saw that the price was high, and these are all the factors which are leading to the high price. And you can see that the first factor which is contributing to this high price is our efficiency, watt hour kilometer.
Okay, so let me try and unpack this, Pranay, right? So you're showing us a chart with all the attributes that lead to the final price of a car.
Yeah.
That's clear. And your machine learning model has shown us that in fact efficiency is that one parameter that contributes the most to the car.
Yeah.
This is fascinating because now it leads us directly to the other question which we had posed amongst ourselves, which is how does this relate to sustainability? So what Pranay has shown us here is efficiency is the BMW car in question actually has the highest efficiency and also the highest price. And what that means is it over the lifetime of a car, let's say we use it for 20 years, because it is so highly efficient, that also means that it will have the least amount of cost in terms of running the car, the electricity price that needs to run the car, because it's highly efficient. And that could then be a strong determinant in whether it's sustainable or not.
Okay,
Fascinating.
fantastic. This is great. Yeah. So can we also kind of saying that this is also a way to overcome our emotional or political decisions? If you look at the data, which helps you justify your emotions or otherwise, right?
Correct.
I think it is also a good practice which everybody should adopt.
Absolutely, Pranay. I think this is important because politics is fleeting. I mean, politics changes from day to day, but data is long term, and data is truth. Right? I mean, there's no truth like data, and so this kind of an analysis actually helps us either validate or say, it helps our head think through what our heart is telling us, and validate whether it is leading us to the right decision or not in terms of sustainability in all respects.
Yeah, no, this is fantastic, Ramani. I think what you said kind of summarizes this discussion in a very good way, that data can help you validate what your heart is thinking, and it will also help reconcile between your head and your heart.
Absolutely, indeed.
So this is fantastic. On that note, I would like to thank Ramani for these very rich discussions. We went from defining on what is sustainability, and then we went into seeing on what are the different EV models which are available out there, and we tried to also link EV to the data. We tried to do some data analytics, and we went through various process on what are the different types of car, how you can kind of cluster them. We also went into seeing on what is the link between all this data and let's say a recommendation engine like Netflix. And we also went into the discussion on how do you link or de-link political decisions while purchasing a car, so that your head and your heart are reconciled. Excellent discussion. And Ramani, would you like to give some final thoughts?
Yeah, no, thank you, Pranay. It's been a very rich discussion indeed. And I think as you've said it all, sustainability is long term, and data is the key tool to help us understand and make the choices between what may be more sustainable and what is less so. And it can help us ratify where our heart may be leading us, and to try to guide the heart in a way that helps us make the right choice and the right decision. Thank you.
Thank you, and wishing everybody a very sustainable future. And if you want to try out whatever I've shown you, you can do so on my platform experienceterrascience.com. Do not forget to subscribe to the channel, like, and give your comments also in the video on what do you think is the future of sustainability and how data can help. Thank you very much.
Look forward.